Hi, everybody. I'm back for part two of the lesson 13. All right, here we go. I'm on number 3. It says rotate HJKLMN 120 degrees clockwise around O. So, again, this is isometric paper. Each of these are equilateral triangles, each which have 60 degrees. Um, So any multiple of 60 will be easy to figure out. So here we go around O. Now what I'm going to do to figure out the 120 is here's O, and I'm going to kind of make this longer so I can see it. So that's one triangle, so that'd be 60. One more, that'd be 120. So I want to rotate it until this piece lands on that piece. I might jot it under here just so I can see it. All right. Okay, so I'm going to hold it steady until this one lands on that one. There we are. So I've got H, N, H prime, N prime, M, L, K, J. And if you want to see again the idea, if you connect, let's do K. I'll do yellow. If you connect K to the center of the rotation to new K, that's 120 degrees. See, 260s. If you did L, that one's not as easy because it's not right on a line, but if you did L to the new L, oops, forgot to put a prime on him, 120 degrees. All right, rotate HJKLM and 60 degrees counterclockwise around P. Let's go back here. Here's P. So I'm just going to kind of make this big again. And I just want to do 60 degrees. That's one triangle there, right? So I'm going to turn this. Now I'm going to show this under here so I can see it. I'm going to turn this until this top piece lands down there, 60 degrees. Right there. Okay, so here's L, M, we'll call this double, K to J, N, I could do this one, color. You want to show yourself, that's 120 degrees. This one, let's do, is L's right lined up with P, so we can see that one. I'll do a different color for you. I'll do pink. If I do L to the center of rotation to the new L, see how that's 60 degrees? You could take any two. And this one was counterclockwise, 60 degrees that way. This one was 120 degrees that way. Okay? So hopefully you had some success there with some patty paper. So the different ways you can rotate is clockwise, moving to the right, counterclockwise to the left. You can rotate using one of the vertices of the pre-image as the center of rotation. You can also rotate around a point that's not on the pre-image. All right, last activity. I'm going to kind of put some of the ideas together. I know I haven't been there for the translations and reflections, so maybe watching me during these might be helpful. They are topics that are talked about in 8th grade math. Translation is just another name for a slide. We just worked on some rotations. Reflect is when we reflect across a line. Okay, Mai suspects triangle ABC is congruent to triangle DEF. She thinks these steps will work to show there is a rigid transformation from ABC to DEF. Now, a couple of the vocab words in these previous lessons are two shapes are congruent if there's a series of rigid transformations that can map one onto another. So if you can do something with slides, rotations, or reflections that can take this onto this, then by definition they are congruent. And rigid transformations are transformations that do not change shape or size. And those are the three that are rigid. Okay? So it says, she thinks these steps will work. Draw each image and determine the angle of rotation needed for this to work. All right, so the first one says, translate by directed line segment. So here's the original. I didn't line that up perfectly, but close. Okay, so see this line right here? I'm going to trace it. That's how much I'm supposed to slide this. Now you don't really even have to trace it. So you see this A, the spot where it ends up needs to be on the end of that. So I'm just going to take this and I'm going to slide it, and it's going to land right there. Okay, I'm going to draw it here for you. So here's the new A prime, B prime is 1, 2, 3, and C is right here. See how that looks. I should be using a straight edge. Okay, so again, look, that's a translation along a directed line segment. That's the way they said. That's showing you, hey, move this that way. Okay. Rotate image so many degrees clockwise around D and then reflect it along over DE. So I'm going to just highlight. So apparently I need to rotate it so that when it gets to here, all I have to do is reflect it straight across this pink line. Well, how much do I need to rotate it? Let's take a look. I need it to land like that. So then this can just reflect right over that. How much is that? Let's see if we can tell. I need this to end up here. How much is that? Look at your triangles. I have to go across two triangles, each one 60 degrees. So that's a 120 degree rotation. Let's try it. Okay, so step 1, translate along directed line segment V. Now we're going to try to rotate 120 around point D. So I'm going to make sure this lands all the way. Boom. And then reflect. Now I really haven't done one of these with you, but reflect along this means if I fold it on that, it's going to line right up. Or you could also just flip your paper. You could go boom, boom. Yep. Oh, I didn't draw where it ended up. Oh, can you tell this also doesn't feel good? Here we go. Rotate 120 lands right here. We're supposed to draw that. So C. So this goes That's C double prime. That's B double prime. And that's still A. And then it gets reflected across line BE. Okay? If there is a series of rigid transformations that can map one shape onto another, then the two shapes are by definition congruent. What is a rigid transformation? Any one of these: a translation, a rotation, reflection, or any combination of those. Okay? So that is what was supposed to be covered this week, and I know a lot of it was review. If you need to go back and watch the Desmos, instead of doing a lot of the things by hand when I wasn't there, I let you do them in Desmos using the transform tool. And there was a teacher in there showing you how to use those tools. I'm going to end this video now. We'll talk about the summary real quick. The three rigid motions are reflect, translate, and rotate. Each of these rigid motions can be applied to any figure to create an image that is congruent. To do a rotation, we need to know three things: the center, the direction, and the angle. So you'll see down here, this one, right? The center of rotation is P. The direction, that would have been counterclockwise. And it was 90 degrees. Let's look at this one. Oh, Miss Austin, did I do that wrong? Because they said this is the original. Oopsie daisy. We're going to pretend this was the original. Original, new. Okay. This one, let's look at the letters this time so Miss Austin doesn't mess up. See how the primes are on here? That means this is the original. So we were going counterclockwise. Here's the center. And look, it's 120 degrees. And by the way, you could say, you could go the other way to get to that same spot. The angle would be different, but I'll be back to do a video of the homework problems. Hope this helped. Bye-bye.